Hi everyone, today we're going to look at the refraction of light experiment. Now, this is slightly different to the reflection of light because we're not looking at a mirrored surface today. We're actually going to look at a glass block in which we're going to pass light through. So you can see that it's made of glass. It's got like a white coating on the back of one side just so that it's a bit easier to see the light as it passes through, but it is totally made of glass. Perspex. Now if I place that to one side just now, I've already drawn round the glass block, and what I've done just now is I've just taken the red laser and I'm just passing it through just to show the direction that it would travel if the glass block was away from it. So the first thing I'm going to do is I'm going to take the incident ray, the light going in, and I'm going to draw a line just as it hits the glass block with a little arrowhead. Now we're going to take the glass block and pop it on top of where we have drawn. What I'm now going to do is I'm going to mark off where the light is exiting the block, again with a little arrowhead. Now what I would like you to do is I would like you to watch where the light emerges here and how that changes when I remove the glass block. Now what we can see is that the light, if it's not travelling through the glass block, travels along this dotted path here. When it has the glass block on top and it has to travel through that material, it has changed direction. It is slightly lower on exit than what it was without the glass block there. And just to prove this again, I'm going to pop the glass block on again, just to show you that it's exactly there. So why does this happen? Why does it change direction if it is entering a new material? It is because the air around us isn't very dense, but as it travels through the glass, it's got a lot more particles closely packed together and it's more dense. So it means that the light has a lot more to travel through, and it slows it down and changes its direction. So if we have this starting ray and we draw it combined with the exiting ray, we should be able to see the path that the ray travels as it passes through. So refraction is when light enters a new material and it slows down and changes direction. Now let's have a look at the refraction diagram in a bit more detail. So I've just redrawn this without the dotted line showing where the light would go when the glass block was removed. So what we're interested in doing now is marking off the angles and labelling what the rays are called, the rays of light. This is where the light comes in to the surface, so this is known as the incident ray. The refracted ray would be the one that changes direction and travels through the block. So it's going from air to glass in this case. Now, I mentioned in the reflection video that we need to measure our angles between the ray and the normal. Now, we don't actually have our dotted normal lines drawn yet, but I did mention that they were drawn at a specific angle. The angle in which the normal is drawn at is 90 degrees to the surface of the material. So our surface is going up and down here, so we would draw our normal at 90 degrees to the surface of the material, like so. And that allows us to label our angle of incidence and angle of refraction. So our angle of incidence would be between the ray and the normal here. So that is I, the angle of incidence. And then angle of refraction, is going to be between the ray and the normal again, here. Now, unlike reflection, these angles are not equal to one another. The angle of incidence is going to be greater than the angle of refraction here. This is because air is less dense than glass. You do need to know how to label these diagrams. So you need to label the incident ray, the angle of incidence, the refracted ray, and the angle of refraction, as well as the normal. So I'll label that for you. So that is part of your PLP that you have to fill in. Another point of refraction happens later on in the glass block at this point here. So you could draw another normal line here and mark off the angle of incidence and another angle of refraction. We mostly look at one point of refraction within the glass block, but if we did continue it on, we would be able to mark off this second one. So if I was interested in doing that, I would draw a dotted line at 90 degrees. The light goes in at this point here. So this would be my angle of incidence. And then it refracts as it leaves the glass block. So this would be my angle of refraction. And again, would label my normal. So that is a fully completed glass block refraction diagram.